Here we go.
Hi, I am Izznur.
I'm Luqman.
I'm Ain.
I'm Imran.
I'm Adawiah.
I'm Adam. Let's answer 10 SPM questions with us.
Question number 1. Cell notation for a voltaic cell with copper and magnesium metal as electrodes are as follows. What is the cell voltage value? Based on the cell notation, we can see that magnesium metal undergoes oxidation at the negative terminal, which is anode, because it releases electron to form magnesium ion Mg2+, while copper metal undergoes reduction at the positive terminal, which is cathode, because it receives electron to form a copper atom Cu. To calculate cell voltage E naught, we can use the formula E naught cell minus with E naught of the positive terminal minus with E naught of the negative terminal. By referring to the value of each metal on the standard electrode potential series, E naught cell is equal to positive 0.34 for the copper minus with negative 2.38 for the magnesium is equal to positive 2.72 volt.
Question 2. Diagram 6 shows the apparatus set up to study the corrosion of metal. Test tube P, iron, test tube Q, copper, and the solution is sodium chloride solution, potassium chloride solution, and sodium hydroxide solution. What can we observe in test tube P and test tube Q after a few days? For this question, you must master about topic acid and bases. And what can we observe? Test tube P will be formed green precipitate. Fe will release electron to form Fe2 plus ions. Test tube Q will form blue precipitate. Cu will release electron to form Cu2 plus ions. Fe will corrode faster than Cu because Fe is more electropositive than Cu.
To answer this question, first you need to know which metal is more electropositive than the other. We can see that zinc is more electropositive than copper. Refer from reactive series. From here, we can tell which metal is anode, which metal is cathode. Zinc will undergo oxidation while copper will undergo reduction. After doing the equation for both zinc and copper, we can make our cell notation. Cell notation must be written according to its technique, which is ABC. A is anode, B is salt bridge, C is cathode. It will look like this. The double line refers to the salt bridge. Anode and cathode must be in solids. For explanation calculation, zinc is more positive, so it will undergo oxidation. Zinc is a stronger reducing agent. Zinc will become negative terminal, which is anode. To calculate cell voltage, we can use the formula cell equals positive terminal minus cell negative terminal. By referring to the value of each metal on the standard electrode potential series. The ENOF of the value is 1.1 volt.
Question 4. Copper dioxide is an oxide of copper. The oxide can be reduced to copper by hydrogen gas. Write a balanced chemical equation for the reaction between copper oxide with hydrogen gas. Explain the redox reaction in terms of change in oxidation number and identify the oxidizing as well as reducing agent for the reaction. First of all, write the chemical equation for this question. Since the number of copper, oxygen, and hydrogen on the right and left hand side is already balanced, there is no need to balance the chemical equation. CuO plus H2 will produce Cu plus H2O. For the oxidation number, when it is a compound, it is ionic. Therefore, copper here is Cu2 plus ion and hydrogen here is H plus ion. Now, we can see that the oxidation number is changed from Cu2 plus to Cu and H to H plus. So, the final answer is oxidation number of Cu2 plus ion decreases from plus 2 to 0. Oxidation number of hydrogen molecule increases from 0 to plus 1. Copper dioxide is the oxidizing agent, while hydrogen is the reducing agent.
Question number 5. Ethanol is an example of an environmentally friendly fuel because of its ability to burn completely and can be obtained from biomass sources such as corn. Draw the energy level diagram for the combustion of ethanol based on the chemical equation. Predict whether the temperature of the surrounding will be lowered or raised. Explain your answer. The combustion of ethanol is an exothermic reaction. When 1 mole of C2H5OH reacts with 3 moles of oxygen to form 2 moles of carbon dioxide gas and 3 moles of the water molecule, 1368 kJ of heat is released to the surrounding. This will cause the surrounding temperature to be raised due to the heat energy released during the formation of the bonds in the product is higher than the energy that is absorbed to break the bonds in reactants.
The heat of combustion of propanol is negative 2030 kJ per mole. A student used 2.16 gram propanol to heat 200 cm3 of water. 6.1. Calculate the number of moles of propanol and the temperature change during the reaction. Molar mass of propanol is given 60 gram per mole. The specific heat capacity of water is given 4.2. Step 1. Find N, the number of mole. Use the formula N is equals to mass over molar mass. 2.16 gram of propanol is divided to 60 gram per mole. We will get N 0.036 mole. Step 2. Find heat change to find temperature change. These two formulas are used. Delta H is equals to Q over N and Q is equals to mc theta. Delta H is the heat of combustion, which were given in the question. So, we can find Q from the information we have. But remember to change the unit from kilojoule per mole to joule per mole. Now, the heat change is 73080 joule. Use the formula Q is equals to mc theta and substitute all the value we have. The final answer is 87 degrees Celsius. In this question, we need to list out how many CHO, carbon, hydrogen, and oxygen we have on both right and left hand side and balance the equation. After balancing, we will get Q equals to 9 over 2 and P equals to 3. Table 4 shows the heat of neutralization for two sets of experiments using different monoprotic acids, V and W, reacting with potassium hydroxide solution. Based on Table 4, name one example of acid V and acid W. Since it is written in the table that acid V and W are monoprotic acid, we can use hydrochloric acid or nitric acid. Explain why there is a difference in the values of the heat of neutralization. As we can see from the table, heat of neutralization of set 1 is negative 57 kJ per mole, while set 2 is negative 55 kJ per mole. Therefore, the answer is set 1 uses a strong acid and strong alkali in the reaction. Set 1 produces a higher concentration of hydrogen ions and hydroxide ion, so the reaction releases higher heat of neutralization. Set 2 uses a weak acid and strong alkali. Set 2 produces a lower concentration of hydrogen ions because the weak acid only ionizes partially in water. Thus, heat is less than negative 57 kJ per mole. Calculate the change in temperature of the mixture in set 1. Specific heat capacity of solution given is 4.2. Step 1. Find N. Use the formula N is equals to mV over 1000, where m is concentration and V is volume. We will get N is equals to 0.1 mole. Step 2. Find Q. Heat change. Use the formula delta H equals to Q over N. Make sure to convert 57 kJ per mole to 57000 joule per mole. We will get Q equals to 5700 joule. Step 3. Find theta, temperature change. Use the formula Q equals to mc theta and substitute all the values we have. The final answer is 13.57 degrees Celsius. First, measure and pour 50 cm cube of 0.1 mole per dm cube sodium hydroxide solution into a polythene cup. Second, record the initial temperature of the solution. Third, measure and pour 50 cm cube of 0.1 mole per dm cube hydrochloric acid into another polythene cup. 4. Record the initial temperature of the solution. 5. Pour hydrochloric acid quickly into the sodium hydroxide solution. 6. Stir the mixture using a thermometer. 7. Record the highest temperature of mixture reached. Now the thermochemical equation involved. NaOH, which is sodium hydroxide, plus HCl, hydrochloric acid, will produce NaCl, sodium chloride, and H2O, water. This is the chemical equation. For the ionic equation, OH minus plus H plus will produce H2O. The heat of neutralization is negative 57 kJ per mole. Why? Because HCl is a strong monoprotic or mono-base acid. And then NaOH is also a strong alkali. Since this reaction is exothermic, we have to draw the energy level diagram like this. But don't forget to write the reactant, product, and the heat of neutralization on your energy level diagram, or marks will be deducted.
Question 8. Polyvinyl chloride PVC is a synthetic polymer. It can be used to make water pipes. Roman 1. What is meant by polymer? A polymer is a long chain molecule that is made from a combination of many repeating basic units. Roman 2. The monomer for PVC is chloroethane. Draw a structural formula of PVC and chloroethane. The first one, polychloroethane. The second one, chloroethane. Third Roman. Explain how PVC can cause environmental pollution, such as on ways to solve this problem. PVC are not easily biodegraded. Combustion of PVC produce toxic and acidic gases. The improper disposal of PVC can cause clogging of the drain leading to flash floods. So, we can mix the polymer with substance that can be composed by bacteria. Reuse and recycle the PVC. Burn PVC in a closed furnace so toxic gases are filtered and absorbed. For this question, you must remember the facts and creative to answer.
For the question 9b, Roman 1, figure shows part of the washing action of detergent particles on grease stained shirt. State the part of the detergent particles that is soluble in grease. The answer is hydrophobic part, tail. Because the detergent particle consists of two parts, which is hydrophilic head and hydrophobic tail. The word philic means love water, so the hydrophilic head will dissolve in water, while the word phobic means afraid of water or hate water, so the hydrophobic tail will dissolve in the grease. For the Roman 2 is, based on the above figure, explain the washing action of detergent particles on greasy stains. So this is a facts and you need to memorize and do practice. And the answer is, when detergent is added to water, the detergent will reduce the surface tension of water and the shirt will wet thoroughly. Hydrophilic part of the detergent anion dissolve in water, while hydrophobic part dissolve in grease.
The hydrophobic part emulsifies and breaks up the large grease droplet into smaller droplet and the emulsifies will suspended in the water. The small droplets repel each other because of the negative charge. Rinsing with clean water will remove the grease droplet from the shirt.
Question 10. State two methods of food preservation which used in our daily lives and explains how the methods work. For this question, you need to memorize and identify the facts that the question wants. So, my answer for this question is common salts such as in dried fish will make the fish last longer as it delay the growth of bacteria. And for the second method, we use benzoic acid inside canned foods. It will inactivate enzymes and prevent food spoiling.